Welcome to MONTCLAIRconnect, the podcast. This series highlights alumni from Montclair State University, the latest programs and initiatives at the school, and how to stay connected. Each episode will speak to a member of the Red Hawk community about their experience at Montclair and what they're currently working on. I'm Dr. Marc Favata, a professor in the Physics and Astronomy department at the College of Science and Mathematics. I'm pleased to be your host on today's episode. Today we're having a conversation with Kevin Johansmeyer, a double alum who received his bachelor's degree in 2017 and Master of Science in 2022. Welcome, Kevin.
Thanks for having me.
So let's start off by talking about your journey to Montclair. How did you, where did you start after high school, and how did you kind of get to Montclair and get to being a physics major?
So I was a student at Burden Community College, a physics student, and I got my associate's degree in physics, and then I transferred to Montclair. I specifically chose Montclair because I wanted to go into education, become a teacher. Montclair has a education program known for that. So that was why I decided to come here.
Awesome. And why physics? Why did you want to do?
So throughout my my professional career, I've never met anyone with the same backstory on why I got into physics.
Yeah.
So actually, I was a skateboarder for basically my whole life leading up to end of high school, and I consider myself still a skateboarder. And all these years I was learning mathematics and didn't really get the importance and didn't really understand why I was memorizing formulas and everything. And then I took physics my senior year, and to me it was just the math behind skateboarding, basically. So basically, like I said, my whole life leading up to that, I was skateboarding, and I'd play the Tony Hawk Pro Skater games actually. Back in the late 90s, and we'd play on PlayStation 1. We'd be in my mom's basement. We'd do a trick in the game. We're like, oh, that's what that trick is called. We'd run outside. We'd try to learn how to do it on our own. And it was kind of like doing informal science experiments. So I was just, after taking high school physics, algebra based, I wanted to learn calculus. I wanted to learn more. Just wanted to learn how the universe worked overall.
Awesome. Wow. Yeah, no, very dangerous path to physics there. And so you came here, you studied physics. We'll talk a little bit more later about, some of the things you did, but then you graduated, and then what'd you do, after you graduated?
So I graduated. I was a high school teacher in Newark for 3 years. And then I decided that I wanted to learn more about physics, learn more about math, debated even going to grad school for engineering, had a couple different options. Montclair actually just started up the applied math masters. Mm-hmm. So I was one of the first cohorts to go through that program and everything. So I did my master's degree for 2 years, and then now I teach at Passaic County Technical Institute.
Okay, and how long have you been at Passaic?
I've been there it's been about this is my third full year, so 3.5 years.
And what are you teaching?
I teach physics, different levels of physics. So we have Physics 1 honors, Physics 2 honors. We teach AP physics like mechanics, E&M, and I also teach AP environmental science.
Okay. So you came to Montclair, you left, then you came back. So you must really like Montclair at some level. So why did you sort of come to Montclair in the first place? And, what made you want to come back as opposed to going somewhere else?
Yeah, so I always tell my students too, the ones I mostly teach juniors and seniors. And I always tell them that Montclair was great enough for me to come back. So I try to promote Montclair as much as possible. I came here, like I said, to pursue teaching, pursue physics. Okay. I came back because, I want to learn more about science and everything.
Okay, very good.
Yeah.
So speaking of science, you and I did some good work together while you were here. So why don't we talk a little bit about that, right? So, there's this LIGO project, which for the folks at home, we could talk a little bit about how that works, right? So basically, at Montclair State in the physics department, we have 3 faculty members who are part of this big experiment called LIGO, the Laser Interferometer Gravitational Wave Observatory. It's basically this $1 billion laser interferometer, and what it does, or what the 2 of them do, is they detect black hole collisions, right? So these black holes are formed from massive stars that end their lives and die, and when they're left over, what's left over is these very compact, dense objects made just of space-time, right? And these dense black holes, these orbiting black holes, they're in these binary pairs, they orbit around each other, and they give off these gravitational waves, these ripples in the fabric of space and time. And those waves propagate through the universe. They hit the detector, and we can register them when they hit this LIGO, this pair of LIGO detectors, and these other detectors in other countries as well. And when we find these waves, we're basically learning about, what are these black holes? What are their masses? What are their spins? How many of them are there? And you and I got working on this project called soundsofspacetime.org, right? It's this like website here that we both developed. And the goal of that website is really to take these gravitational wave signals, which just look like an oscillating wave, and convert them to sound waves, right? And, the reason we want to do that is because the gravitational waves they're more like sound than they are like light, right? So we kind of want to build some intuition about gravitational waves and try to understand like how they work. How can we get a feel for how does the signal depend on, the properties of the black hole that's producing that signal. So, given that background, maybe you can talk a little bit about, the project that you worked on while, you were a master's student and what came out of that.
Yeah, so one of the big motivations behind this project and going back to school and doing my master's was to make something tangible to use in the classroom. So I knew about gravitational waves a little bit when I was an undergraduate. Some of my friends were studying with you. And to me, it seemed very intimidating, and there was a big barrier of entry. I guess like the first step would probably be to take your general relativity class. And, high schoolers, they want to learn about like the cool physics stuff, but we have to learn to walk before we could run. So we have to learn about Newton's laws and everything like that. But they want to jump to the black holes, the quantum mechanics, all that stuff. So my goal was to kind of bridge that, because most of my students, regardless of what school I taught at, probably won't go on to be a physics major and then take like an upper level general relativity class to learn about this. So I made this application in JavaScript. Going into graduate school, I didn't know anything about JavaScript, HTML, CSS, any of that stuff. So I was learning that on the fly and everything. And there are these gravitational wave events where these detectors detect gravitational waves, and basically they're categorized in a bunch of different ways. They're mostly categorized by the date. So they're all labeled GW and then have like the year, the month, and the day after it. The first gravitational wave detection was September 14th, 2015. So when you go to the webpage, the first detection there is on the webpage. Then there's
we can take a look at it here, and you can play one of the, play. So here we have like one of the signals, right? Like this is the signal from that first gravitational wave event, which was in 2015, right? September. And the first time like black holes were ever observed colliding together, right? And so here it's showing essentially the amplitude as a function of time, right? And it's a short thing. It just lasts like 0.6 seconds, 0.7 seconds. And why don't you go ahead and play it, and we can get an idea what it sounds like.
There we go. Yeah, that's a good one.
Okay, right. So here we got this like oscillating signal, right? It goes, right? So that's like essentially, it's not the gravitational waves don't make sounds, but if you could take that signal and convert it to an audio stream, it's basically a representation of the orbital motion of the two black holes spiraling around and then colliding together. Right?
So this application is great, especially for teaching high school students, because it runs in the browser. So a lot of schools use Chromebooks, so it's very accessible. There's no packages you don't have to download. You don't have to run like a Python script, anything like that. And it's just very accessible overall. So I use this in my classroom. I've used it both in Physics 1 and Physics 2, depending on what topics we're talking about. And the biggest misconception that students have with it is they think this graph is the gravitational wave. So I have to tell them that isn't a gravitational wave. That's the signal that the detector is seeing when it detects the gravitational wave.
Yeah, no, that's a good point. So what do you do with it more specifically in the classroom? Like how do they, what do they play with it? They got to do some assignment with it. What do you have them do?
Yeah, so they use the website. They go through all the events. So we have every single gravitational wave event that is published in the website.
Right. So far, up to this date.
Up until right now, yeah.
More coming that won't be in here.
Yeah.
Right?
And then as they there's a drop-down menu. So like I said, very easily accessible. They go through, they look at the data associated with it. So if we click another event and we scroll down, they'll see a table with values. And then they can also cross-reference this with something called the stellar graveyard that also shows these other events. So this is a kind of less interactive, but also online and accessible tool for students to explore these events. So they check to see if the data matches. They see what caused the events. There's descriptions on these different things. So this event here on screen is a black hole neutron star merger. So you could tell based on the masses that are there. So the one event, the one object, the black hole is about 30 times the mass of the sun. And then the neutron star is just over one mass, one solar mass. So they have very different masses, which creates an interesting waveform. So people that are really well versed in this can see the graphs and they could tell what type of event that is, maybe even approximate like the masses and everything.
Yeah, we could try playing this one. This one's probably... But this was a really neat application that you made. And so you must have learned a lot of stuff like making this thing. So what are some of the, I guess, transferable skills that you picked up while you were, learning how to do this?
Yeah, so while I mentioned this is in HTML, JavaScript, CSS, the data comes from Python. So there's a Python package called lol simulation. Mm-hmm. And with my experience, there wasn't a lot of documentation on it. So going to Montclair and working with you and Dr. Ghosh was a great experience because if I was at home trying to do this, I would not be able to figure it out. So working with real experts that understand how to use the Python packages, the ins and outs of it, without totally formal, concrete documentation. The data is all in basically like giant Excel files. They're called HDFI files. And you have to learn how to navigate them and manipulate the data and filter out the data is probably a better way of saying it, using Python and programming everything. So that was probably the biggest thing to even access the data in a meaningful way, export it, and then generate waveforms based on that data.
Okay. So let's talk a little bit more about your experience as a physics student and as an applied math student more broadly. What were some of the, besides this project you worked on and, what were some of the other, I guess, highlights of your time as a physics major, let's say, or as an applied math, master's student?
The biggest thing I can think about is being president of the physics club. So when I was president of the physics club as an undergraduate, I met a lot of people really fast, which was great because I was a transfer student, as I mentioned before. So I transferred in and I knew one person and he didn't actually know me. So it was kind of a one-sided thing. So essentially, I really knew nobody coming to the school. And I joined physics club my first semester, and then they were looking for new officers for my second semester. And those positions last a year. So while I was president of the physics club, we did different outreach. We ran different events. I built like the gravity well for you.
I remember that.
So that was through physics club. Out of tent poles. Yeah. And spandex and everything. So we built a hovercraft.
I remember the hovercraft.
So we had all sorts of projects going on. It was a great way to meet people on campus, do something that was extracurricular. So applying for jobs, they really look for that stuff. Like, having good grades only kind of, gets you so far in everything, in my opinion, especially getting your first job. So I was really happy to have all that like hands-on extracurricular experience with it.
Okay, awesome. Yes, no, I remember when you were president, and the physics club ran very well when you were in charge. So what are some of the other like things that you got not just out of the physics program, but just out of your time at Montclair? Like, what are the things that sort of helped you, going forward, you know, in the rest of your career or other areas of your life? You know, like what did you get out of that college experience besides, I guess, like physics knowledge and math knowledge and coding and things like that?
I also got a lot from the education program too. So as I mentioned, you know, I came to Montclair partially to study physics, partially to become a teacher and everything like that. Montclair has a really great education program. I learned a lot about different perspectives and different ways of life than I grew up, specifically in like inner city schools and different problems they face and everything. As I mentioned before, I worked in Newark, so that helped me prepare to work in an environment that I wasn't exactly familiar with.
Right.
So that was you know, a great thing for me.
Okay. What was the, I guess, aside from physics club, what's the most fun thing you did, you know, at Montclair as a student?
I just had a great time socializing with people. Like I had friends that weren't physics majors as well, especially right when I started, because when I started here and didn't know any of the physics majors, I kind of relied on like hanging out with people I knew from high school and their friends. So I had some good times like hanging out at the Village, which is like the nice apartments on campus and everything like that. And then as I kind of got like my you know, groove with my physics friends, I kind of went that route instead of hanging out with people I knew from high school, I guess. But yeah, it was all good memories. I can't really think of anything bad.
That's okay. We don't need to talk about bad things. That's good. You know, so if you were to give advice to some incoming student, let's say, about, you know, their time at Montclair and what to get out of it, let's say, you know, what would you tell them?
Just get involved in things. That's the best way to do it. When I was in high school, I was barely involved with anything. You know, we had like a high school band. We played in a few things here and there. Nothing crazy. Wasn't in any clubs, wasn't in any extracurriculars, nothing like that. When I was at Bergen Community College, I was like I wanted to do that stuff, but I was a little bit afraid. Like there was a math club, but I was like, you know, I was in like Calc 1 at the time, and I was kind of intimidated that there'd be people that knew more than me. And I've just realized that like clubs are very, very welcoming. They're very low stakes. They're actually looking for people that are probably like more of a freshman with like less knowledge and everything, so that they could pass down that knowledge. Like when I ran physics club, we did a lot of like tutoring sessions where it was just like, hey, come in. Like a lot of students in like college level physics with algebra based have trouble. So we wanted to be welcoming and accommodating and have those people come in, and we wanted to help them. That's a little bit less intimidating than working with like a professor or going to their office hours. So we try to kind of bridge the gap for like those kind of students.
Okay. So getting involved. Give me another one. You know, give me another piece of advice for a student or something you wish you knew.
Something I wish I knew. To park in, I don't know, should I give the parking secrets, or is that?
No, do not give out the parking secrets.
Okay, so
you have to keep those.
Yeah, so those are
figured out on
near.
your own. All right. Well, thanks a lot, Kevin. This was a great conversation. Glad we had a chance to reconnect today. Montclair Connect, the podcast, highlights alumni from Montclair State University, the latest programs and initiatives at the school, and how to stay connected. This podcast is a collaboration between the Alumni Engagement Team and the College of Communication and Media at Montclair State University. To get involved as an alumni or learn more about what's happening at Montclair, visit montclair.edu/alumni. Thanks for listening.